Welcome back, happy fabricators. In this video we're going to show you how to convert your MIG welder to be able to weld aluminum. So the first thing you're going to do to make sure that you can do this conversion on your welder is make sure it's an actual MIG welder. So in the acronym MIG, the G on the end stands for gas, and we need to make sure that on the back of your machine that you've got a gas port here on the back that gas can flow in and through your machine. If you just have a flux core machine, unfortunately in that case this isn't going to work for you. Next thing you're going to do is make sure you have some 100% argon. So since we're welding aluminum, we can only use pure 100% argon. Unlike traditionally when you're welding with mild steel, you're going to be using like a 75-25 mix or CO2. Since we're welding aluminum, just like when you're TIG welding aluminum, we're going to need to use 100% argon. So we're going to get that hooked up to the machine. And then once you've got your gas all sorted out, you're going to need to order up some Teflon or graphene liners. So what this is the liner is the piece of steel that goes inside of your whip or stinger or MIG gun, whatever you want to call it, wherever you're at in the world. And traditionally, when you're running either hardcore or flux core wire through it, it has a helical tube on the inside of it, which we'll show you in a little bit when we change these out, for that wire to travel through. And sometimes that wears out and sometimes you have to replace it. But since we're going to be running aluminum wire through this whip, we are going to replace it with this Teflon liners. So Teflon is a really slick and slippery kind of plasticky material, and it's going to allow that aluminum wire to travel through it with less resistance and have less chance of getting all bound up. So first thing we're going to do is swap this over is we're going to open up the side cover, and just like we would normally change out our wire, we're going to get rid of our mild steel wire. And then I'm going to take the end of my nozzle, take the end off, and grab that wire and pull the rest of it through so we don't have any more wire in the end of our whip. And then we can go, and every machine's a little different. Mine has a wing nut right here that we can loosen this guy up with. Some are set screws. Then you should be able to just pull on the front of this and bring that out. And then every machine's a little different here. The prime weld has a little connector on the front side that twists and pulls out. Some machines, the wires go up inside and you have to disconnect the lugs to pull them out. Now once you got the wire pulled out from the end of it, I like to use some flat jaw pliers so that I'm not marring stuff up. And most of these are righty-loosey. So we're going to grab the diffuser, loosen that up and get it off. If you see right here, that little helical tube that's coming out is the liner that I was referring to. So it is steel, and we would not be able to successfully run aluminum wire through this. So once you get the diffuser off the end of your gun there, we're going to come to the opposite end, and there's often, every welder is going to be a little different, but in this case I got a little tiny set screw that we're going to undo here. And then I'm going to take my pliers, I like them flat jaws so I'm not marring stuff up, and grab them and pull that liner out. And there we go. So now that we got our original liner out, I'm going to take our Teflon liner. Now I've got a blue Teflon liner here that is good for 0.06 to 0.09 wire, so up to 30 thou, which is what I'm planning on doing here. But I'm going to take it out and I'm going to make sure that we have the same length of the new liner. And you want to start on these ends here. Now, every machine is going to be a little different. You'll have to kind of do your due diligence. I picked this one up off of Amazon, and I think it's going to work. It's not exactly the same as my factory one, but actually, like right as I walked out here to do this video, I think I actually found the one that works for my model of the factory torch. So I'll leave a link to that if I actually find it when it comes in. But this one that I got here also should work. If you have a prime weld and you're following along with this because you've got a prime weld also, the newer MIG 180s have a Tweco style torch, which a lot of machines run the Twecos. You'll just need to look up and see what Teflon end fits on the Tweco style torch, if that's the case. Nonetheless, we want to run down this, make sure we have the proper amount of length, which we're good. We're a little long. I'm okay with that. Now this one has this little wire into it, and I'm going to clip that off. So I'm going to take this, so we're long here, and I'm going to clip this like, I don't know, 6 inches longer for now, because I know I don't want this metal piece on the end here. But I don't want to clip it to the exact length yet. And then I'm going to take the end of it and run it down just like you would normally change out your liner. Now, something to consider is once you do your aluminum, you don't want to switch right back over and put steel into this liner. It would probably work for in the short term, but this is the thing that happens when you change your liners. It would probably work in the short term, but that steel is going to abrade this nylon and going to wear it out very prematurely. So you would definitely need to stick the other liner back in it if you're jumping back over to steel. That sounds like a pain in the butt. So what I'm gonna do is I got a hold of another lead, and I'm just going to have one stinger set up for aluminum and one stinger set up for mild steel, so I don't have to change the liners out each time. Okay, and there we have it. So I'm gonna make sure that our end piece is all the way seated in the lug, and then for mine, I'm gonna take and just shear that off because there's not enough room on the inside for that little piece of Teflon to seat. And then I think I'm going to just put a little bit of a chamfer on this so that I can get, maybe even take a countersink so that the wire will get started easier into the Teflon right here. Or I can do it with a razor blade here. There we go. So then now that we got that through, we can stick our lug end back in the machine. Make sure it's seated all the way. And lock down your set screw on the inside. And then on this end, I'm going to look at my diffuser, and I've got about a 1/2 inch of room before it necks down in there. So I'm going to take and cut this off about a 1/2 inch long for this to go over top of. Another thing, just from experience working with this Teflon line, I use Teflon line at my work, and what you can do is when you go to cut it, it will kind of pinch it and leave some sharp edges. So kind of round it out with your tool, and then take your torch and just lightly fire the end of it. Hit it with the flame just a little bit, and that will kind of like roll over the edges and just kind of melt the edges so it's a nice smooth edge all the way around it, and it's a lot less likely that that wire is going to get caught on anything. Now we should be able to screw our diffuser back on, so it should be lefty-tighty on this guy. And there we go. And then another thing I'm going to do is I'm going to change out the size of my contact tip. So we're going to be running 030 wire, which is what I normally run through this, even with MIG welding steel. But what I've found over the years, especially running spool guns and stuff, is that if you jump up a size on your contact tip, aluminum expands and contracts a little more easily with temperature fluctuations. So what I've found is you just have less problems if you're running aluminum through a MIG gun, whether it's a spool gun or a MIG gun. You'll just have a lot less issues on both your spool gun and hopefully this if it works good. So now that we got this set up, we're going to load our wire in. Now I've got some 4043 and I've got some 5356 here both. I have a hunch that the 5356 is going to work better in this scenario because 5356 is a little more rigid. The 50 series wire, it has more tensile strength, so therefore I have a feeling it's going to be more reliable pushing it through the whip. But I just kind of want to try the 4043 and see if it works at all, and if it doesn't, we'll switch it over and run some 5356. Okay, so now I got this in here. A couple things to consider is you do not want to tighten this reel down super tight because we just want this aluminum to be able to have very little resistance when it's pulling. We want to minimize the chance of this thing bird's nesting. And that being said, also in conjunction with that, we want to loosen up the drive roller on this thing. So I loosen this thing way up. We're going to turn the machine on. Another thing you'll notice is I left the contact tip out while I'm loading this because if it doesn't go straight into the contact tip, that's also going to cause things to back up. So we're going to leave the contact tip off, turn our machine on, let it turn on. Oops, forgot to plug the gun back in. That's why it's not working. There we go. Turn our gas off because we don't want to waste any gas. and let this thing feed through. It looks like it's feeding pretty well. This machine has a cool feature where it speeds up when you're loading the wires, so you don't have to sit around so long. Oop, I heard something hit. I'm just going to take the diffuser off so I don't ball anything up. Yep. Oh no! As soon as that hit the diffuser, we balled up down here. Well, we'll try this again. This 4043 might not work in here. Okay, round 2. So I'm going to loosen up the drive roller even more, so hopefully it'll slip before it rat's nests in here again. Try it again. And we're going to leave the diffuser off here as well. Hey, there we go, we're through. Now we can stick our diffuser, stick our contact tip on, our shielding cone, and we should be ready to weld now. Now, my machine was already set up, MIG welding, we want to be electrode positive. So if you were flex core welding with this, you need to switch it back over. Mine, the lugs are right on the outside, which is super easy to get to. Some machines, actually have lugs with nuts on them on the inside, and you have to undo the bolts and flop those around. But let's see how this works. So I'm gonna get my settings based off my little chart that I have on the wall there that comes with my prime weld. Most machines just have their chart on the inside of the door so you can reference that, or if it doesn't have anything for referencing spool gun settings, which I'm going to kind of generally base these off of, I'm sure there's stuff online that you can access there. We've got some Weld Metals Online coupons, coupon code for those in the description if you want some good practice coupons. Oh, other thing, I'm running the gas just a little higher. Found that works better with the spool gun. I'm basing a lot of this stuff off of my experience with a spool gun, so I'm running like closer to 30 CFH, excuse me, dyslexic. That is not too shabby. I think I need to turn my wire speed and voltage up just a little bit. We'll show you what's going on here. So as you can see, I was just a little bit cold in the beginning. As I went along, it heated up. I could feel it just dragging just a little bit inside the liner, but it wasn't too bad. Let's run another one. That is working a lot better than I thought it was going to. Let's do some more. Man, I just did a horse trailer repair this week, and this would have been so much easier than dragging a TIG welder out there, because this would just weld dirtier material so much better than laying down with a TIG welder. Ouch, that's hot. This is looking really good. This is still hot, but focus, grasshopper. There we go. That is a pretty clean little MIG weld. Now this is 16th inch. I'm going to bump this up to some 1/8 inch. And okay, we got some 1/8 inch material cleaned up here. And the one thing I am going to do with the 1/8 inch, oh actually, before we go anywhere, because I know people are going to ask, the 16th inch, our settings were at 15 volts, 320 inches per minute on wire speed with the 16th inch material. We're going to bump that up for the 1/8 inch material. And the other thing I'm going to do, going back to my experience with spool gunning, is we're going to preheat our start just a little bit. I wasn't too worried about it on the 16th inch stuff just because it's so thin, but once you get above 1/8 inch or 1/8 inch and above, preheating your start makes a huge difference whenever you are MIG welding aluminum, whether it be like this or I'm assuming like this, or with a spool gun. Just enough to get that start nice and clean. Okay, we had the tiniest of hiccups there. We burnt back into our tip just a little bit. I let off the gas. I had just a little bit of burn back. If you have a fancier machine, like if I did this on the Prime Weld MIG 285, that has burn back settings. So I know other machines, some Lincolns, some Millers have burn back settings also, and that can help to minimize the chance of that happening. But so far it's looking really good. I think I'm going to crank up the voltage and wire speed just a hair more and keep on trucking. A couple things that I'm looking at when I'm going here. I'm making sure that I definitely have a push angle. Whenever you're spool gunning or MIGging with aluminum, you definitely want to have a push angle to kind of shield that area out in front of the weld. The other thing I'm doing is you have a larger contact distance. So when you're MIG welding, you're kind of more in like a 3/8 of an inch, or maybe like, I don't know, 9 millimeters. Whereas when you're doing aluminum, you want to be back more like almost 5/8 of an inch, sometimes 3/4, depending on what you're doing. You're gonna have a lot longer arc length, basically, is what you're looking for. Okay, so I'm going to call that a success. I'll show you what we've got here with the 1/8 inch material. Got some of the coupons that I played with here, and that is not a horrible aluminum MIG weld. There's definitely been better in the world out there for sure. It's not the best, but for a quick, budget-friendly, not a push-pull gun, just your standard everyday MIG welder, I say that's acceptable. Out of the 16th inch, we also got some nice looking stuff here. You go, not too bad looking, you can see. And I'm sure if I sat here and practiced with this thing, it would be even better. This is just about 10 minutes of me fiddling with this thing. I would definitely say when I go out on a job, I'm definitely gonna bring some coupons so that I can do some quick practicing, because the settings are definitely finicky. You don't have as much grace as you do when you're MIG welding mild steel as with this aluminum. So another thing, this 1/8 inch, the sweet spot setting, at least for this machine that I've seen when I was playing around with it, and these are analogs, so I know the newer prime welds and a lot of machines are digital, so you might not be able to get exact, but it looks like I was about at 16 volts and about 440 inches per minute on the wire speed for the 1/8 inch. I mean, this machine can go all the way up to 500 inches per minute on the wire speed, so I'm sure I could weld probably roughly up to like 3/16, maybe even quarter if I preheated it enough with this setup. So I'm super happy with that. Another thing to consider is, I don't know if you've seen on my 1/8 inch one here, is the weld is very dependent on the temperature and the material. So as I was starting out on this side, you can see it doesn't flow into it as well. It's still a decent weld. I would still use it for repair. But as you got further on, you can see the profile got better and those toes were wetting in just a little nicer. So something to consider. That's why it's kind of important to preheat your starts whenever you are spool gunning or MIG welding aluminum. And then also just to consider your sequence of welding. If you see that that weld is getting hot toward the end of your weld, maybe you need to move on to another side of the part and weld a little bit and then get back over to where you're at and just kind of work your way around so that you don't overheat the part and your welds go downhill from there. Like I said earlier, I have some 53-56 wire, but I don't think there's really any use in me trying it. Okay, so unfortunately, or maybe fortunately for you guys, I couldn't resist myself and I just had to throw the 53-56 in there to see what it would do, and I actually learned some interesting things. It's better and worse in some regards. As far as the wire itself traveling through the liner, not getting hung up, it works much better. It's not as finicky, but it does not weld as good, at least with this machine, or I don't know, maybe that's in general. I actually kind of find that in general with the spool gun. I find that the 53-56 doesn't weld as good, but the things that I did learn is it likes a little less voltage and a little more wire speed than the 40-43 does. But I'll just show you kind of some comparisons here. I was just padding beads, and it wants to run a little hotter and you get just a little more soot on there. That one's not horrible with the soot. You can see some there. Whereas with the 40-43, and check that out, these are just nice, clean. There's like almost little to no soot on these things. I was just playing around and thought I'd share that as well. Back to the other part of the video. I more had it as a backup if the 40-43 failed. And since the 40-43 worked, I'm gonna consider this experiment a success, because If the 4043 works, the 5356 is definitely going to work. It's a more rigid, robust grade of wire, so it's going to feed through better. I mean, this definitely, you could tell it was finicky. If you didn't hold your stinger out straight, you would feel it catching a little bit, but it was still very doable. Like I said, if I had this set up last week when I had that horse trailer repair that I did, this would have been so much nicer and easier than laying on my back with a TIG welder, welding in horse pea saturated aluminum. So let me know what you think down in the comments below. If you would have done anything different, if you have any wisdom on how to do it better, I'd love to hear it down in the comments below. So once again, if you want to see more fabrication content, click some of the links that are going to pop up here. If you want to be notified of upcoming videos, hit that subscribe button and ring the bell. It's free to do so. Go build something, guys. I'd say that holds pretty good.